Hello everybody, our lesson today will talk about comparing and ordering rational numbers. First, representing the rational number on the number line. Draw a number line like this and put 0, 1, 2, 3, 4 and so on. All integers are rational numbers, as we said before in the previous lesson. Like if we put 0 over 1, it will be 0, 1 over 1 it will be 1, 2 over 1 is 2, 3 over 1 equals 3, 4 over 1 equals 4. 0 over 2 and 1 over 2, 2 over 2, 3 over 2 and 4 over 2. 0 over 2 equal 0. 2 over 2 equal 1. 4 over 2 equal 2. So we have an integer here and fraction here. So number line contain fractions and whole numbers. So 1 and 2 between them a lot of numbers like 1.1, 1.2, 1.3 and so on. 1.175, 1. And a lot of numbers between 1 and 2. So between any two consecutive whole numbers there is an infinite number of decimal. 3 and 4 we have a lot of numbers between them, like 3.1, 3.5, 3.2, 3.4, 3.8 and so on. So if we choose this number as example, 3.85, we have here 3 in whole number, so 3 bigger than 3 and less than 4, because 3.853 include between 3 and 4. So between any two consecutive whole number, don't forget this, there are an infinite number of rational numbers. 3 over 4 on number line. How can we draw it or get it? We draw a number line, but 0, 1, 2, 3, 4 and so on, and negative 1, negative 2. 3 over 4 it means we get 0. Is it whole number? No. Whole number? No. Whole number? No. Here 4 over 4 equal 1. Very good. Where is 3 over 4? It's between 0 and 1. It's here. So we put a dot here and determine 3 over 4, and 3 over 4 it means 3 parts out of 4 parts of the whole. 1 over 4. What can we do? Draw a number line with 0, 1, 2, 3 and so on, negative 1, negative 2 and 3 and so on. Divide all numbers by 4. So where is negative 3 over 4? It's here. We determine the whole number, 0 over 4 and negative 1. Negative 3 over 4 between 0 and negative 1. So it's bigger than negative 1 and less than 0. Excellent. In this 4 we do what? We convert it into improper fraction like 7 over 4 and write the numbers 0, 1, 2, 3 and so on here. So we need only positive numbers. Put denominator 4 on whole in all numbers, and the whole number is 0, the whole number is 1, the whole number is 2. So 7 over 4 here between 1 and 2. Then 1 and 3 over 4 bigger than 1 and less than 2. Another example. Here we simplify first negative 15 over 9 by dividing by 3 or by your calculator. It's the same. It will be negative 5 over 3. We need negative 5 over 3. We draw number line and put 0, 1, 2, 3 and negative 1. And your denominator will be what? 3. Excellent. 3 on all numbers. So 0 over 3, negative 1 over 3, negative 2 over 3 and so on. We need 0 here and negative 5 over 3 is here. Before it, negative 3 over 3 it will be negative 1. And here negative 6 over 3 equal negative 2. So negative 5 over c here between negative 2 and 1, negative 2 and negative 1. So negative 2 and negative 1. Negative 2 and 1. Which is bigger? 1, because 1 is positive. Negative 5 over c and 1 over 2. 1 over 2 is bigger because 1 over 2 is positive. So 7 over 3 and 2 over 3. The denominator is the same, so the biggest one up is the bigger. Here 4 over 5 and 4 over 7. Up like up from grade 3, therefore down is smaller, it means it is the biggest one. Here we have 4 and 2 over 5 and 4 6 over 5. We have the whole number is the same, so the fraction in bigger one is the biggest. 3 and 6 over 7 and 2 and 8 over 9, which is bigger. In whole number we have 3, so 3 is bigger. 3 over 4 and 2 over 5. How to determine the biggest one? We have two methods to do it. Like, make it the common denominator by times 5 up and down in the 3 over 4 and times 4 up and down in 2 over 5, like this. It will be 8 over 20 here, and the other side is 5 over 5, 15 over 20, which is bigger, 15 over 20. Or by cross multiplication, like this, 5 times 3, 15, and 4 times 8 equal 2 times 8. So 15 bigger than 8. In this example, we have a decimal number and a fraction. We convert 13 over 10 into a decimal fraction, a decimal number. It will be 1.3, which is bigger, 1.3 or 3.2. We have the whole number is 3 and the whole number is 1, so 3.2 bigger than 1.3. So we need to arrange these numbers ascendingly or descendingly. We first get LCM, least common multiples of the denominators, is 12, because 12 divisible by 2, 6, divisible by 4, divisible by 3. So we make all of this common denominator like this. In the first fraction, we multiply by 4 up and down to get negative 8 over 12. And second fraction, multiply by what? To get 12 in denominator. Okay, multiply by 3 up and down. It will be 9 over 12. And third fraction as it is. Fourth fraction, we multiply up and down by what? Excellent, by 2. 2 up and down, it will be 10 over 12. And last one, negative 1, is a whole number. So it will be negative 12 over 12. Therefore, we have 8 over 12 and 9 over 12 and negative 7 over 12 and 10 over 12 and negative 12 over 12. Arrange ascendingly from the smallest to the biggest one. The smallest one is negative 12 over 12 and negative 8 over 12, excellent. Negative 7 over 12, 9 over 12 and 10 over 12. The density of rational numbers between two any natural numbers or rational numbers, we have a lot of numbers between them. We have 2 over 3 and 3 over 3 and 4 over 3. 3 over 3, it mean what? It mean 1, whole 1. We can multiply by 2 up and down. It will be 2 over 6. And the other one multiply by 2 up and down, it will be 10 over 6. Between 2 over 6 and 10 over 6 we have 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6, 8 over 6, 9 over 6. We have a lot of fractions between 2 over 6 and 10 over 6. 2 over 6 it means 1 over 3, and 10 over 6 it means 5 over 3. If we multiply by 3 here and multiply by 3 here, the fraction will be 3 over 9 and 15 over 9. Between 3 over 9 and 15 over 9, 4 over 9, and a lot of numbers, 5, 6, 7, 8, 9, 10, and so on till 14. So if we have a lot of numbers between 1 over 3 and 5 over 3, like 2 over 3, 3 over 3, 4 over 3, 3 over 6, and 4 over 6, and 5 over 6, 6 over 6, 4 over 9, 5 over 9, and we can do it another time. Between any two rational numbers, there are an infinite number of rational. Another example, 1 over 4 and 3 over 4. We have 2 over 4 only? No. We said an infinite number of rational numbers. So, if we multiply up and down by 10, it will be 10 over 40. Up and down by 10, it will be 30 over 40. So, we have a lot of numbers between 10 and 30, like 11 and so on. For example, find the three natural numbers between 5 over 2 and 3 over 4. First, we must have the same denominator. We multiply here by what? 2 up and down, it will be 10 over 4, and 3 over 4 as it is. Between 10 over 4 and 3 over 4 we have 9 over 4, 8 over 4, and 7 over 4. We need only 3 digits or 3 fractions. We choose any 3 fractions of them. For example, find 4 rational numbers between 1 over 2 and 5 over 3. First, we take LCM of the denominators. It will be 6. So we multiply up and down by 3. Very good. It will be 3 over 6, and the other one by 2. It will be 10 over 6. So between 3 over 6 and 10 over 6 we have 4, 5, 6, 7, 8, 9. To get rational numbers lies between any two rational numbers. 1. Both of these rational numbers must have the same denominator. 2. If you need, multiply both of this rational number by any number, 2 or 3 or 10. Thank you and goodbye.